Okay, let's take a look at adding and subtracting rational expressions now. Okay, and just continuing with our theme, adding and subtracting rational expressions is very similar to adding and subtracting regular fractions, okay? And so I underlined right here, a common denominator is needed when you're adding or subtracting fractions. And that's why adding and subtracting is more difficult than multiplying and dividing. Okay, so just in general here, if P over R and Q over R are rational expressions, notice that they already have a common denominator of R. We can write it like this. P over R plus Q over R is the common denominator on the bottom, and then you can just go ahead and add the top. Okay, and if you have subtraction, it's still just the common denominator on the bottom, and you could just subtract the top. Okay, but you have to be a little bit careful, especially with subtraction, because these P and Q are full polynomials. So that Q could be multiple separate terms, and then that negative would have to distribute. Okay, so we'll watch out for that as well. Okay, if rational expressions do not have a common denominator, this is where it starts getting a little bit tricky. What we need to do is factor the denominators completely, and then multiply the numerator and denominator of each rational expression by the factors that each one was missing from what would be the least common denominator. Okay, so it's going to be a somewhat similar process to trying to find common denominators with regular fractions, but we're just going to do it in a more formal process because we're dealing with factors of polynomials rather than just numbers. So anyways, let's do a few examples and you'll start to get the hang of it. So here we go, perform the following operations and then simplify. Okay, so this first one here, notice that it's already got a common denominator. Okay, so that's awesome. If you've got a common denominator already, the result is just going to be that denominator, and then it's just going to be the polynomial and then minus the other polynomial. So it's going to be 5x minus 3 and then minus, and here's where I'm talking about being very careful. I want to use parentheses 2x minus 9 on that full separate polynomial because, like I said, minus has to distribute. Okay, so let's go ahead and rewrite this. 5x minus 3, and then it's going to be minus 2x, and then that'll turn into plus 9. And then simplify this. 5x and minus 2x can combine to 3x, and then minus 3 and plus 9, that can simplify to plus 6. Okay, once you get to the end, once in a while, it's not very common, but once in a while, you can continue to simplify and possibly reduce further. So I'm noticing that we can factor a 3 out of the top, but none of that is the same as the bottom, right? So technically, we didn't need to factor that 3 out because it didn't cause any extra simplifying or reducing, but once in a while, it is possible to keep reducing. So go ahead and factor it at the end if possible, but then, yeah, nothing is in common there, so that one's done. Okay, part B. For this one, we do not have a common denominator, so we need to think about what would be the common denominator here. So we don't have these other situations where we have to factor yet, but we just need to think, if these were regular fractions, what would be the common denominator between the 10 and the 25? And so you got to think about it a little bit. So you got to think, okay, 10 and 25, what's the smallest thing that can be divided by both of those? And after a little bit of guess and check, I think 50 works. Okay, would you agree with that? So I'm going to write down the common denominator that we're thinking about. What would be the common denominator? So between the 10 and the 25, it's got to be a 50, but then we also have to consider the variables. So with x squared and x, okay, well, it's got to be the minimum thing that can be divided by both of those. So x squared can be divided by both x squared and by x, and that's the minimum requirement. Okay, so that's the common denominator that we need. So we need to do a little bit of work, and this is what I'm saying. You want to multiply, just like we would with regular fractions, the top and the bottom of each by what it was missing. So let's show that step here. We need a 50x squared. So this first one, to turn the 10 into a 50, we need a 5, and then it already has x squared, so it doesn't need any extra x's. So for this one, it's got to be a 5 on the top and the bottom, And I'll go ahead and write all of this out so that we really see where it's coming from. Okay, plus, and then for this second one, what do we need to multiply the top and the bottom to get a 50x squared on the bottom? We need a 2, right? 2 times 25, and we also need an extra x. So this one needs a 2x on the top and the bottom. Okay, so now straight across the top, this one becomes 15 over 50x squared. And straight across the top and bottom, this becomes 14x over 50x squared. Okay, so yeah, a little bit more complicated when there's polynomials involved, when there's variables involved, but now it's 50x squared as the common denominator, and we can go ahead and just add up the top. 15 plus 14x. And there's no simplifying or reducing or canceling that can be done, so that is the answer. Okay, let's think about this one now. So for this one, you have to factor everything. Okay, and so this is what I'm talking about. You definitely want to factor everything completely because we need to try to see what do they have in common. So for this one, I just want to do some quick scratch work and realize that this is the same as x plus 5 times x minus 5. So we need to think about it. What would be the common denominator? Okay, so we got to think about what is the smallest thing that can be divided by all of these different pieces. So we need an x plus 5 involved, and we need an x minus 5 involved. This one has the x plus 5 already, okay? And so the common denominator would just have to be the x plus 5 and the x minus 5. Those are completely separate terms, okay? So be a little bit careful. It's kind of tempting to think about it as all we need is like an x and a 5. But x plus 5 is a completely different thing than an x minus 5. For example, if you plugged in a 1 for x, then that's going to be like a 6 and a negative 4. And those numbers are completely different, okay? So whenever there's variables involved, you just need to consider the entire factor as its own separate thing. Okay, so we need to take this now, and we need to multiply the numerator and the denominator of each of those rational expressions by what it was missing. Okay, this first one, it wasn't missing anything, right? The common denominator needs to be an x plus 5 and an x minus 5. That already had both. So that one is not missing anything. Let's just rewrite it. This one's not missing anything. I definitely want to rewrite it using the factored form. Okay, but that one's not missing anything. Okay, then we have minus, and I'll write it on this side, 6 over x plus 5. What is this one missing? This one is missing an x minus 5, right? So we need to do an x minus 5 on the top and the bottom. Okay, so now it's going to be, and maybe I'll write one more step here, we have the 12x over x plus 5 times x minus 5. Over here we have minus, and now this is where you have to be a little careful because it's a good idea to go ahead and distribute. I have the minus out front here, so I'll take care of that later. For right now, I'm multiplying that 6 in here. So it's going to be 6x minus 30. On the bottom, don't distribute. Leave everything alone. If everything's factored, it's way better. Okay, so continuing, this is now going to be x plus 5 times x minus 5. And up here, now we can go ahead and write it as 12 minus all of that, 6x minus 30. And then this is where we need to keep track of that negative. Okay, so we're going to have 12 minus 6x, and then distributing, we get plus 30. X plus 5, x minus 5. And then combine like terms if possible. So I'm noticing 12 plus 30, that can be 42, and minus 6x, x plus 5 times x minus 5. And I'm also noticing that the 42 and the 6, 42 is divisible by 6. So if we wanted to, I don't think it's going to do any extra reducing, but I'm going to go ahead and do it. I'm going to factor out a negative 6, and it's going to switch this to positive x and minus 7 when I factor it out of the 42. It didn't cause any reducing, so it's technically not necessary, but I always like to write it as the nicest possible factored simplified form. All right, but if you entered your answer like this other one in like a homework program, it'll accept it as correct. Okay, but if there's like some multiple choice question and you don't see this as an option, this is the one that we would have to look for. So just keep that in mind. All right, so yeah, definitely more difficult to deal with adding and subtracting rational expressions than multiplying. So let's do a couple more. 3 over 5x plus 2 over x plus 1. Okay, so thankfully, nothing can be factored, so we don't have to worry about any of the factoring, but what would be the common denominator here? So it's kind of tempting to just think about it as like a common mistake would be to say 5x plus 1. And that's incorrect because 5x is a completely different thing than an x plus 1. And so like for example, if you plugged in like a 1 for x, that's going to be a 5 and a 2. What does a 5 and a 2 have in common? Nothing, okay? So the safe way to deal with this, whenever you've got the variables involved, is just completely use them as separate things. So 5x is its own separate thing, and it also has to have the x plus 1, okay? Because that's the minimum thing that I could divide by both of those. Okay, that's just what we got to do whenever you've got these weird variable expressions. Okay, so let's continue this. We're going to multiply the numerator and the denominator of each of these by what they were missing. So this first one was missing the x plus 1. So let's go x plus 1 over x plus 1 times the 3 over 5x. Okay, plus this one was missing the 5x. So let's go 5x over 5x times the 2 over x plus 1. Okay, so now straight across the top, maybe do my distributing. Be a little careful there. So it's going to be, let's see, 3x plus 3 over, don't distribute the bottom. We always want to leave the bottom already factored. That's not the stuff that we want to combine. We want to see if it's possible to combine the numerator. So just go ahead and leave it like that. Okay, then we have plus. Straight across the top here is 10x. Okay, on the bottom, the order doesn't really matter of how you multiply those. I could switch those around as 5x times x plus 1. The order doesn't matter. It looks a little bit nicer maybe if you put the 5x in the front. And then now we just go ahead and add up straight across the top. So let's go ahead and just do that. 3x and plus 10x is 13x. And then there's that 3. And there's no other factoring or canceling that can be done, so that is it. Okay, when there's plus involved, I think it's a little bit easier. You can go ahead and just try to think about combining like terms right away. If there's minus involved, you definitely need to be a little bit more careful, okay? Because it's really tempting to start combining like terms, but this minus has to distribute into all of the pieces over there. So with plus, you don't have to worry about that quite as much. Okay, part E. How do we add that? What's the common denominator? Like, how could we possibly even add a 1 to this? Okay, so just like when you're dealing with regular numbers, any whole number, you can write it as over 1. Okay, so then what's the common denominator? The common denominator between a 1 and an x plus 1 is just x plus 1. It's really easy to turn that 1 over 1 into an x plus 1 over x plus 1. So let's write this first one as x over x plus 1 plus, and now this, I'm going to write it as 1 over 1, and it needs an x plus 1 over x plus 1. So then we have x over x plus 1 plus, and this is just kind of a silly extra step that I wrote, but I wanted to emphasize that it's still the same process. And then now it's x plus 1, and then we can go ahead and just add everything up, 2x and plus 1. Done. Okay, so that one's an easy one, but I just wanted to demonstrate that, yeah, you can actually just add a regular number to a rational expression as long as you think of the denominator as a 1 and then get the common denominator. Okay, part F, this one is definitely going to be one of the ones that you want to focus on for really understanding this topic. First of all, let's factor everything and try to think about what the common denominator would be. So this is kind of just my scratch work here for factoring this. Let's see, for 12, how about 4 times 3 plus and plus to make it add to 7? That looks good. Over here, this is a difference of squares, so that's x plus 3 times x minus 3. All right, so here's the part that's a little weird. What is the common denominator here? And we want to think about what's the minimum thing that we need that can be divided by both of those parts. Okay, and the way that I think about it is it's just like, all right, there has to be an x plus 3 involved. Okay, there has to be an x plus 4 involved. Okay, and then over here, there's also an x minus 3, which is a completely different animal than x plus 3. There has to be all of those different parts involved. Okay, and we don't need to write the x plus 3 twice. Okay, it's just whatever factors that you see, they all just have to be involved once. Okay, unless any of them were like squared or something, then it would have to be involved with the minimum amount that you can use. Okay, but yeah, x plus 3 has to be involved, x plus 4 has to be involved, and x minus 3 has to be involved. So here is what the common denominator would be. Let's rewrite this by multiplying the top and the bottom of each of these by what it was missing. So this first one, with the x plus 3 and the x plus 4, it was missing the x minus 3. So let's write that, x minus 3 on top and bottom for this one. And then I just want to rewrite this with this all factored. Okay, minus, usually when there's minus, I put the other work on the other side. So I'll just write this as the 3x like here. And then this had the x plus 3 with the x minus 3. So this one was missing, the x plus 4, right? This one is missing the x plus 4. Okay, so let's keep going. So here, let's try to do this in as few steps as possible. So that is going to have to distribute into both of those. So we will get 2x squared minus 6x. And the denominator is really just all of this junk. Don't multiply it all out. Just write it all next to each other. Don't FOIL this out. Okay, then we're going to have minus, and we'll deal with the minus a little bit later. This has to be distributed. So that's going to be 3x squared and plus 12x. And again, don't distribute anything out on the bottom. And the order doesn't matter. I just want to make it look the same as I did on this side. So I'll go ahead and put the x minus 3 in the front, then the x plus 3, and then the x plus 4. We can rearrange the order down there because it's multiplication. Okay, and then in as few steps as possible, let's go ahead and write it as x minus 3. I'm trying to do as few steps as possible for the sake of time, but I invite you to write down as much as you feel you need to be comfortable. So with this minus, it distributes onto here and it distributes over here. So we're going to have 2x squared minus 3x squared. That's negative 1x squared. We have minus 6x, and then this is going to be a negative distributing on the 12, so that's going to be minus 18x. Okay, I'm looking at this, we can technically factor out like a negative x, but it's not going to cause any reducing. Maybe I'll just do it. I'm going to factor out a negative x, and we're going to get x plus 18 left over, and then there's not really anything that happened there. But just to emphasize, it's usually a good idea to try to do any extra factoring and reducing at the end if possible. All right, so yeah, that one's about as crazy as it can get because we had to factor and the common denominator needed 3 separate pieces. And then the same process is going to work though. You just go find out what that common denominator needs to be and then multiply the top and the bottom of each of those expressions by what it was missing for the denominator. Okay, I have one last page where we're going to solve some rational equations. So I'll make one last video and we'll finish off this topic.